Welcome to IM1 11.2, video 1 of 2. The idea here is all about reflections, and we got 5 boxes to talk about. So let's dive right in. For us, what is a reflection is box 1. So hopefully this is familiar to you. A reflection is a transformation that uses a line, that uses a line like a mirror. And I think the best way to show you like what this is just to like show you what it looks like when we have a demonstration. So let me do that for you here. So let's bring this in. Okay, so as you can see on the left-hand side, I have triangle like AEF, and then on the right-hand side, I have A prime, E prime, and F prime. So the line BC down the middle is my reflection line. So if I just move this triangle around, you can see that no matter what I do, it is reflected on the other side. So we're using that line BC as kind of like a mirror. So think of it like that as what a reflection is. So hopefully that makes some sense to you. Okay, so that's our little demonstration for it. In box 2, let's talk about a little example here. It says graph triangle ABC with the vertices and its image after a reflection is described. Okay, so for part A it says described in the line x equals 3. So the first thing that we have to do is actually graph the line x equals 3. So 1, 2, 3. So this right here is the vertical line, x equals 3. So I'll go ahead and draw that for you. Here's the line x is equal to 3. So now, how do I reflect that? Well, if I look at A is at 1, 3. If I reflect that over the line, I am going to be over here. That's a reflection of that line. So I have to figure out where would that point happen to be. So that would be A prime, and that would be at 1, 2, 3, 4, 5, 3. So that would end up at 5, 3. Okay, B is at 5, 2. So if I reflect it over the line, notice I'm 2 units away. So if I'm 2 units away from my line of reflection, then I'm going to go 2 units away back on the other side. So this would be point B prime. Okay, and that would be at the point 1, 2. And then same thing here. If I am 1 unit away from C, from line x equals 3, then I'm going to be exactly 1 unit away from C on the other side as well, reflected over. So that point would be here, and that would be C prime, and that would be at the point 1, 2, 3, 4, 1. So all I was really doing there is just sort of counting the points up. And if I connect them, I'd have that guy, and that guy. So the blue line, or the blue shape, is my pre-image, and the red or sort of orange shape is my image after the reflection. So that would be part A. Part B says, how about in the line y is equal to 1? Okay, so similarly, again, we have to graph the line y equals 1. So y equals 1 is a horizontal line right here, where y is equal to 1. Let me draw that better for you. Right there. Okay, so let's graph our line y equals 1. Okay, and we're going to reflect it in that line. So basically, I'm going to tip this blue thing upside down over on itself, okay? So notice that C is going to stay right there because there's nowhere to reflect, right? But for A, I can count that I'm 1, 2 units away from the line of reflection. So I'm going to go 2 units in the line of reflection in the opposite direction. So this would be A prime. B is right here. I'm 1 unit away from the line of reflection. So again, I'm going to go 1 unit away from the line of reflection down. And this would be B prime. And that would have everything I need to draw my new shape. And remember, the first shape, the blue shape, is called the pre-image, and the orange shape is called the image afterwards. So there's everything you need for box 2, reflecting in a horizontal and a vertical line. Just count how many units away you are from the line of reflection, and then go that same number of units in the opposite direction for every single point. Okay, box number 3 is all about something called a glide reflection. Now, a glide reflection is just a transformation involving a translation followed by a reflection. So let's write that down, okay? A translation followed by a reflection. Now we learned in the last video that a translation is just sort of a movement left, right, up, or down. And a reflection, we just figured out, is moving something over a line like a mirror. So we can actually put these two things together and it's still considered a rigid transformation, okay? So let me show you an example of how we do this in box number 4. So it says graph triangle ABC, and we have that done for you. There's the vertices for A, B, and C, and its image after doing a translation of mapping xy to x minus 12 comma y, and then reflecting it in the x-axis, okay? So before we get started, we have to remember our little transformation rules. To translate xy to x minus 12y, we're just going to subtract 12 from every x value. So if my x value is located at 3, 2, I'm going to subtract 12 in the x direction. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my new point would be right there. So let's put that in there. Okay. And where would that point be? That'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be the point -9, 2. You can just count, or of course you can just do what I did and use the little scale to help you out. Okay. Same thing with B. Let's subtract 12. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I would be right there. Okay, there's B prime for us. And then lastly, C again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So I'd be right there. Okay, there's my C prime. So there is my translation of x minus 12 and then y. Notice that the y value didn't change, so we didn't have to go up or down, anything. Then after that, what it wants us to do is reflect this over the x-axis, okay? So again, the x-axis is here, and I'm going to count how far away I am from that x-axis. So it might be helpful to actually draw the x-axis in, and remember that that is my line of reflection. So if I go from 1 unit there, I'm going to go 1 unit over, and we'll do this in green for you so you can see it nice and pretty. So there is C double prime. Okay, likewise, B is here, so right there. So I'm going 3 units. So 1, 2, 3. So B double prime is going to be there. And then lastly, A, 2 units away, so I'm going to go 2 units in the other direction over there. So this is going to be A right there. Double prime. And then notice that this shape has kind of like turned over on itself because it's a reflection. So we can do 2 translations and then a reflection, or a translation then a reflection, and it's still considered a rigid transformation, but this is what's known as a glide reflection, when you're doing one and then the other. Okay, lastly, in box number 5 here, we're identifying lines of symmetry. So a figure in the plane has line symmetry when the figure can be mapped onto itself by a reflection in a line. And of course, the line that we would of reflection is called the line of symmetry. So let me give you an example of what this means. So how many lines of symmetry does each hexagon have? These are all hexagons. So notice they all have 6 sides to them, but they have different lines of reflection. So here's what we're going to do. The first one, if I drew this line right here, okay, and I basically folded it over on itself, would it map to itself? And the answer is yes, it would map to itself, right? Is there another one? Yeah, there's another one. There's this one here. So if I folded this this shape over on itself, folded the hexagon over on itself, would it map onto itself? So this one has 2 lines of reflection. Okay, a hexagon, if I draw the sort of diagonals here, that would be 1, then 2, and then 3. So this one looks like it has 3, but there's actually more because since it's a regular hexagon, I can go here 4, 5, and 6. So this guy would have 6 lines of symmetry, because on any one of those lines, if I fold the hexagon over on itself, it would map to itself. In part C, there's actually only one, and it would be right here. And the reason there's only one is because if I tried to, a lot of students want to do this, just like start to connect the diagonals, but clearly if I folded it along that line there like a sandwich, it would not intersect or not map onto itself. So this one, the last example, only has one line of symmetry. So 2, 6, and 1. Okay, that is everything you need for the first video in 11.2.